So, good morning, good evening, good afternoon. Hello, everybody. What we're going to do is we're going to be reading the abacus. So we have my abacus. We have to do 7,952. So on the abacus, we're going to do 7,952. So we have 7, 5, 6, 7, 9, 5, 6, 7, 8, 9. We have 5, and then we have 2. Hello, everybody. Hello, welcome, welcome, welcome. We're going to be learning how to read the abacus. After we learn how to read the abacus, we'll see if we can actually do anything with the abacus. So we have 7. Notice that these are not counted, but these beads are counted. Anytime the beads are touching the reckoning bar, this is what's counted. So we have this number is 5, 6, 7. This is counted. All of these beads are being counted. And then we have this is counted. This is 5. But these 4 beads are not counted because they're not touching the reckoning bar. This 2 is counted, but these 2 are not counted because it's not touching the reckoning bar. And then we have this one also is not counted. So we have 7,952. So we're going to color it in our abacus, 7,000. So we have 7. Hello, everybody. Thank you so much for joining. Thank you so much for liking the live. I'm trying something different. So thank you, everybody. Thank you, everybody. Welcome, welcome, welcome. So we have 9. So we have 5, 6, 7. 5, 6, 7,000. We have 900. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Thank you so much for liking the live. And then we have 5. The top bead will always be 5 no matter what. Notice these are counted. These 5 beads are being counted. This 5 is not touching the horizontal bar, the reckoning bar, so it's not counted. So then we have 2. We have 1, 2. So we have 7,952. Thank you so much for liking the live. So our next number is going to be 4,178. We have 4. 1, 2, 3, 4. Notice the 5 is not touching the reckoning bar, so it's not counted. Again, this is 1. These 3 beads are not counted, and this 5 is not counted. So, hello, hello, hello. What we're going to do is we're going to put in our number. We have 4, 1, 2, 3, 4, 4, and then we do 1. I'm just coloring it in. And then we do 7, 5, 6, 7. Our next number is 6,003. 6,003. Oh, there we go. Hello, hello. Technical difficulties. Thank you so much. Thank you so much for being patient. Hello, everybody. Okay. Oh, that's not what I wanted. Fit to screen, make it centered. Okay. Hello. Welcome, everybody. Welcome. We are learning how to read the abacus. Thank you, everybody, for joining and being patient. We are going to continue. So we have our next number. Our next number is 6,338. 6,000. 5, 6, 1, 2, 3, 1, 2, 3, 5, 6, 7, 8. Thank you so much, God's angel JJ, for sharing my live. Thank you so much for sharing my live. Hello, everybody. So we're going to do 6. So we do 5 and then 6. We do 3. 1, 2, 3. Thank you so much, God's angel JJ, for sharing my live. I appreciate that. So we have 1, 2, 3. So we do 1, 2, 3, and then we do 8. 5, 6, 7, 8. Hello, everybody. Hello, welcome, welcome, welcome. And so our next number is going to be 4,918. So we have 0 on the abacus. None of the beads are touching this reckoning bar. And then we're going to do 4. That's what 4 looks like. The 4 beads are touching the reckoning bar. 1, 2, 3, 4. Our next number is 9. This is 9. 5, 6, 7, 8, 9. Thank you so much for the follow. So we have 9, and then we're going to do 1. 1 and 1. 1 bead. So notice that these beads are touching the reckoning bar. And then we have 8. 5, 6, 7, 8. So then we have 4. 1, 2, 3, 4. 9. 5, 6, 7, 8. 9, and then 1, and then 8. Thank you, everybody. Thank you, everybody, for joining. I'm going to color it in. We do 4. And then, there we go. Bada bing. So we have 9, 5, 6, 7, 8, 9. And then we have 2, 1, 2. And then, thank you. Thank you so much. I appreciate that, your favorite Louisiana. So we have, oh, I made a mistake. It's supposed to be 1. And then 8. 5, 6, 7, 8. There we go. Sorry. So this is a mistake. It's supposed to be just the 1. So notice anytime the beads are touching the reckoning bar, what we're doing is we're visualizing our numbers. Thank you so much for the comment. Your favorite Louisiana. Thank you so much. I appreciate that. Okay. So what's our next number? We're going to zero it out, and we're going to do 8, 9, 2, 0. 8, 5, 6, 7, 8. We have 9, 5, 6, 7, 8, 9. And we have 2, 1, 2. Thank you so much for sharing my live, Miss Boyd and Miss B. And then this is 0. So when we're looking, we're visualizing our numbers. We have 5, 6. We have 5, 6, 7, 8. Thank you, Hoover Dam, for the follow. We have 9, 5, 6, 7, 8, 9. We have 2, 1, 2. Notice that these beads are touching the reckoning bar. Because the beads are touching the reckoning bar, these are what being counted. This is not counted. This is not counted. So what we're looking is these beads are not counted, and this is not counted. So we have 8, 9, 2, 0. 8,920. 20. And I'm going to color it in on my abacus. We have 8, 5, 6, 7, 8. We have 9. Ooh, not something I think. Of course. Hello, Jadelyn. Yes, it is very different. But the cool thing about it is that we're visualizing our numbers. So you can see that this is 8, this is 9, this is 2. So our next number is 8, 1, 2, 5. 8, 1, 2, 5. We have 8, 5, 6, 7, 8. We have 1, 2, 1, 2, and then this is 5. The top bead will always be 5 no matter what. Notice these beads, these top beads are not touching the reckoning bar, so it's not counted. If the top bead did touch the reckoning bar, now we have 6. If I did this one, then we would have 7, but they're not. This is 1, this is 2, and then that's 5. So we're going to color it in. This is 5, 6, 7, 8. We're visualizing our numbers. After we visualize our numbers, let's see how we do with adding and subtracting. You can add, subtract, multiply, and divide on the abacus, but it does depend on how the timing goes. So our next number is 3,074. So 3,000, I'm going to clear my abacus. We have 3, 1, 2, 3. 0, 7, 5, 6, 7, and then 4. 1, 2, 3, 4. We have 3,000. 1, 2, 3. We have 0, 7, 5, 6, 7, and then we have 4. 1, 2, 3, 4. So what we're doing is we're reading the abacus and we're visualizing our numbers. We have 3, 0, 7, 4. Oh, there we go. Okay, so we have 3, 0, 7, and then that's 4. That's what it is. So what's our next number? Our next number is 7,335. So we have 7,000. I'm going to clear my abacus. I have 7, 5, 6, 7. I have 1, 2, 3. 1, 2, 3. Oops. And then 5. So now I'm going to color it in. We have 5, 6, 7. I have 1, 2, 3. And again, 1, 2, 3. And then I have 5. The top bead will always be 5. So that's what we have. Hello, everybody. Hello. Thank you so much for joining. So our next number is going to be 6875. Clear my abacus. I have 6, 8, 7, 5. Now you notice all of these top beads are touching the reckoning bar. So these 5, the top bead is counted as 5. So these are all being counted. So we have 6, 5, 6. 5 plus 1 is equal to 6. 5 plus 3 is equal to 8. 5 plus 2 is equal to 7. and then there's the 5. So when we color it in, we have 6, 5, 6. We have 8, 5, 6, 7, 8. 7, 5, 6, 7, and then we have 5. Hello everybody, thank you so much for joining. And then our next number is going to be, great, thank you so much for the follow, Kendra. Okay, so our next number is a 3-digit number, but just because it's 3-digit doesn't mean we're going to use all of our columns. We're going to use our 3-digit, which is 5, 8, that's what 8 looks like. Oh. And then 7. 5, 6, 7. So we have 5, 8, 5, 6, 7, 8, and then 7. 5, 6, 7. Notice that the top bead is touching the reckoning bar, so that's counted. We have 5 plus 3 is equal to 8. 5 plus 2 is equal to 7. So we have 8, 5, 6, 7, 8. We have 7, 5, 6, 7. That's it. So our next number is 7,016. So now we're using 4 digits. 1, 2, 3, 4. 1, 2, 3, 4. We have 7, 5, 6, 7, 0. That means none of the beads are touching this reckoning bar. We have 1. That's what 1 looks like. And this is 6. 5, 6. So then we have, color it in, 5, 6, 7. We have 1, and then 6. 5, 6. Oh, and then we're almost done. We have our last number. We have 2,781. So I'm going to color it in. We have 2,000, 1, 2. Again, the 5 is not touching the reckoning bar, so we're not going to count it. But this one is. This is 7, 5, 6, 7. So we're going to color it in 5, 6, 7. We have 8, 5, 6, 7, 8. 5, 6, 7, 8. And then we have 1. That's what 1 looks like. All right. Are we ready? It is now going to be your turn to let me know what numbers these are. So, what are we doing? Okay. We have this one. Let's see. There we go. All right. So, for those of you that are interested, let me know what you think this number is. What number do you think this is? Right here in the start here. So our number, I'm going to clear it. We have our thousands, we have our hundreds, we have our tens, and our ones. What number do you think that is? I'm going to color it in while I wait. So we have our thousands. We have our hundreds, our tens, and our ones. What number do you think that is? Oh, hold please. Oh, there you go. Oh my goodness, there's a lot of people. Yes, thank you so much, everybody. 3,732. Hello, Maylin. Thank you, Lou, Vinny, Ella, Real, Gospel, and Emily. Well done. You guys are doing pretty good. Wow. Okay, 3,732. That's what that looks like. Okay, so then our next number is, what number do we think this is? Whew, that was a lot of people. Okay, we have our next number. We have our thousands, our hundreds, our tens, and our ones. What number do we think that is? Uh-oh. There we go. Ah, yes, thank you. Nobody. Yes, 9,695. Well done. This is not working. There we go. There we go. Thank you so much, Nobody Special. Thank you so much, Lou, Real Gospel. Yes. So it's 9,695. What number do we think that is? Well done. Thank you guys so much for liking the live. What number do you think this is? We have our thousands, our hundreds, our tens, and our ones. 9,000. Hello, Michael. Welcome, Michael. How are you doing? Oh, thank you so much, Lou and Nobody Special. Well done. 9,325. Well done. Thank you, Michael. Thank you. Thank you, Lou. Awesome. You guys are doing a really good job. I want to pin that. Okay, great. So our next number is, that's 9,000. So we're doing this over here. I need to cover that. There we go. So what number do we think that is? We have our thousands, hundreds, tens, and ones. What number do we think that is? Woo! Nobody special. You're so good. Yes. Well done. Thank you, Real Gospel. 5,420. Thank you, Michael. So we have that number. Okay, so it takes us to this one over here. What number do we think that is? I'm so glad I found a channel where a lady is using an abacus. Okay, answer seeking channel. We have thousands, hundreds, tens, and ones. Well done. We have 8,000. Well done. Am I bleeding? No, it's my red pen. My red pen is bleeding. Oh. Yeah, it just happens to be, yeah, anyways. 8,145. Well done. Thank you, Nobi Special. Well done, well done. And then we have our next number. 8,000. Yes, this is it. What number do we think this is? We have our thousands, our hundreds, our tens, and our ones. What number do we think that is? Thank you so much for liking the live, everybody. Thank you so much for liking the live. Yes, well done, Michael. It is 6,511. Well done. Well done. All right. So we have 6,511. That's what that is. And then it takes me to here. What are we doing? What are we doing? We have our thousands, our hundreds, our tens, and ones. 1,987. Well done. And it takes me to this number over here. Oh, hold on. There we go. What number do we think this is? We have our thousands, our ones, our hundreds, our tens, and our ones. Exact same pet. You know what? These are very old. Yeah. Thank you, Michael. Yes. It is 2,119. Thank you, Maylin. Thank you, Nobody Special. Well done. Well done. Okay. And so our next number takes us here. I love these pens, but they leak. So our thousands, our hundreds, our tens, and ones. Yeah, time to get a new pen. I know, right? Thank you. Can we do decimals? Yes, Nava, yes you can. Decimals are over here. Yeah, Michael, I gotta get a new pen. You're right. I should get a new pen. But right now I'm a little stuck. 9,166. Yes, thank you. So, Nava, just to let you know, yes, you could do decimals. If you notice, this is my ones place. So this is my ones, tens, hundred, thousands. Then after the ones, I have my tenths and I have my hundreds. So after the ones is my decimals, my tenths and my hundreds. Okay. So we have this number. need to do this one instead. All right, what number is this? We have our thousands, hundreds, tens, and ones. Oh yeah, no, thank you, Nava, for the. I recommend the Sharpie. Thank you for the question, Nava. That's a really good question. I do have that one. I just wanted to get rid of all these old ones that I have. Well done. Well done. And then we have this number over here. Thank you, Nava, for the follow. Thank you, Nava, for the follow. Okay, we have our thousands, our hundreds, our tens, and our ones. What number do we think that is? Welcome, everybody. What we're doing is we're learning to see and recognize our number, visually recognize our number. That's what we're doing. We're visualizing our numbers. What number do we think that is? Let's see if I could do that. And can I do this? So I can do that. 800, 8,000. Well done. What's an abacus? An abacus is a counting tool. This counting tool helps us. Thank you, Chaotic. Welcome back. Welcome back, Chaotic. This is what tells us how to read our numbers. Thank you, Michael R. Thank you, Michael. It is 8,088. Well done. Sud FX. Does that make sense? So what we're doing is we're visualizing our numbers. We know that this is 8, 5, 6, 7, 8. This is 0 because none of the beads are touching the reckoning bar. This is 8, 5, 6, 7, 8, and we have it again, 5, 6, 7, 8. If you notice, every column is a place value. So we have ones, 10. We are finally to the end. Hi, Chaotic. Thank you so much, Affinity, for the follow and the share. All right, so our last number is thousands, hundreds, tens, and ones. What number do we think that is? Whew. Hello, everybody. Hello. Thank you so much for joining. Thank you, Michael. 8,742. Well done. Well done. Okay, that's it. That's it. That's all I got. No, there's more. But wait, there's more. Okay, so there's 23 of us. I am wondering, what should we do? Should I continue on with the lesson? How many people are new here? Let me know. For those of you who are new, put in number 1 for new. If not, I don't know what I'm going to do. So, for those of you that are interested, this is a abacus. An abacus is a tool to help us read numbers. So when we're looking, we want to do this. If you notice, I have my ones over here. Ones, tens, hundred, thousands, 10,000s. If you notice, there is this label. There's these dots, and this will tell me what my ones is, and then it will label, because it's grouping, this is my thousands. So just as we have our number, 5,000, 003, we can do that. We could do 5,003. So that's what this dot means, right? It's a label. I could choose this one to be my ones place. If I did that,
Pokemon, I choose you!
Then I'd move everything over and I'd be here. So then this would be 5 point, like that, 5.003. And then I can do a really small number. I could do 0.00001. So it would look like this. 0.000123001. That's what that would look like. Hello. Are we were I don't even know. That's not even proper English. Back using an abacus now? No. I don't know if you know how to use it. If you know how to use it, good on you. All right. So what's our next number? So that is, there it is. Does that make sense? So it all talks about the place values. And when we're looking, right, you might be wondering, well, I choose this one over here. Why? Because now I have enough room for my ones, tens, hundred, thousands, and 10,000s. We are using the abacus now. Yes, and it's better than the slide rule because the slide rule didn't survive. Michael, you wish there was a slide rule, but this is not a slide rule. Oh, that's not good. There we go. So, yeah. Thank you, everybody, for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Wait. Thank you, Michael. I appreciate that. For those of you that are interested, we are learning how to read the abacus, and when you notice, we could do 5 plus 2 is equal to 7. So the question would always be, is there enough? We can do like 8 plus 1, 2 plus 7, and then 3 plus 6. The question is do we have enough? If I have 1, can I have 8? Yes. 5, 6, 7, 8. Yes, we do have enough.
Yes, we can.
We can add it, and there we go. That's what we did. So what did we do? We could do it again. If I had 2 on the abacus, right, and I want to add the 7, can I add the 7?
Yes, we can.
Yes, we can. So then we have 3. We have 3 on the abacus. We have 3. 1, 2, 3. Can I add the 6? Can I do it?
Yes, we can.
Yes, we can. We can add the 6. And notice my answer is 9. What abacus does is we do not focus on the second number. We don't focus on the result. We focus on the second number. We see whether or not we can add it or not, right? So then the other question is, like, if I had 5 plus 2, if I notice, if I have 5 on my abacus, can I plus the 2?
Yes, we can.
Yes, we can. We could do 5. Or you could 2. 1, 2, and we just add it like that. So my final answer is 7. Notice the question will always be, can I add it? Yes, we can. What happens when we don't have enough? Well, just like this question over here, let's see if I can find my stuff. Oh, I didn't bring it. Did I bring it? So if I had... Oh, I hear it. I don't hear it. Oh, I forgot it. Nope. Sorry, I'm trying to find something. I don't think I brought it. It's not here. So what are we doing? I'm still looking for the slide rule tutorial. Good luck, Michael. Good luck. I'm not the one to do the slide rule, just so you know. I only do the abacus. This is a Japanese abacus. This Japanese abacus is a 1 and 4. 1, 2, 3, 4. So for those of you that just joined, let's do a little review. We're gonna do 1, 2, 3, 4, and then 5. That's the value of 5. We have 6. We have 7, 8. And then 9. Well, you might be wondering, what about 10? This is 10. We have a 1 and a 0. I don't know where it is. I am so lost. Sorry, I'm trying to find something. I don't think I can find it. Oh, nuts. Sorry, I'm trying to find something. Hold, please. I thought I had everything available and ready. Maybe here? What? Oh, here it is. There it is. Okay, got it. Okay, so you might be wondering, what if we did 4 plus 4? Slide rule. Hey, Pesmo! Slide rules are playing trying to read it. There are books for slide rules. Yeah, I'm not about to read the slide rule. So the question, here's a question. So if I want to do 3 plus 4, this is going to be easy. I know it's going to be easy, but the question is what? It's the 3 on the abacus. I'll have 3 pennies. 1, 2, 3, 1, 2, 3. And I want to add the 4, but to add the 4, I don't have enough beads to add the 4. Guess what I can do? I can actually use a 5. I can actually use this nickel, but if I use this nickel, that's too much. I have to take away the 1. So I have to take away the 1. So my final answer is 7. 5, 6, 7. I could do it again on my abacus. I could do the 5, take away the 1. So my final answer is 7. 5, 6, 7. And that's what my answer is. We can do it again with a 4. What are we doing? 4 plus 4. We're not going to memorize our doubles. What we're going to do is we're going to understand the concept. The concept is 4 plus 1. Oh, you can't see that. The concept is 4 plus 1 is equal to 5. What are we doing? We're taking this 4 and we're isolating it. Isolating it means that we're going to make it by itself. So we have 5 minus 1. That's what we just did. So my question is 4 plus 4. So if I have 4 in my abacus, 1, 2, 3, 4, right? 1, 2, 3, 4. There we go. And I want to add the 4. I want to add this 4. This 4 is the same thing as this 4. So guess what I can do? I could substitute. So if I substitute, the live is lagging for me. Oh no! If it's lagging, then that means I won't be able to do this. So I have the plus the 5 and I take away the 1. Oh, that's probably why there's only 37 of us in the room. Oh no, Michael, thank you so much for letting me know. So we have 8, 5, 6, 7, 8. Notice I could do it again on my abacus. 5, take away 1. Oh, really? Okay. I will continue on. Thank you so much, Winorific. Thank you, Winorific. Thank you so much. Does this make sense? I hope it's okay. Let me know if it's okay. So we can do it again, right? My final answer is 8. 5, 6, 7, 8. How did I do that? Because what I did was I substituted this information into here. Yeah. So now it's the 5 rule. Yeah, it's been lagging since I got here. I thought it was me. Oh no, chaotic. That's not good. Actually, it's me because I'm actually on the road and I'm trying to see if I could do something different. Oh no. Yes, Plasmo, thank you. It is the 5 rule. So when we're looking, we could do it again with a 3. If I did 3 plus 3, well, guess what? It's the same thing. I actually have 3 plus 2 is equal to 5. 3 plus 2 is equal to 5. Guess what? I'm going to isolate this variable. This 3 is going to go here, right? That means that this 2 has got to go out to the other side of the equation. So it's 3 is equal to 5 minus 2. How am I going to do that? Well, if I have 3 on my abacus, 1, 2, 3, I can add my 5. Add my 5. I need to take away the 2. Take away the 2. So I could do it again on my abacus. My final answer is 6, 5, 6. I could do it again on my abacus. I add the 5 and take away the 2. My final answer is 6. We can do it again with the 4. So I have 4 on my abacus. I want to add the 3. What are we doing? We're understanding the concept of the 5 rule, just as Plasmos mentioned. We have 4 on the abacus. I want to add 3. Notice what I'm going to do is 3 plus 2 can equal to 5. That's what this 5 is for. But we're going to isolate it, right? We're going to isolate the 3 and we're going to make the 2 on the other side. So it looks like 3 is equal to plus the 5 minus the 2. So we have plus the 5, take away the 2. My final answer is 7. 5, 6, 7. Oh my God, Plasmo! I did the 1 to 100. Can you show representation of basic? I can try. Let me see. So, oh no. Let's see if I can find it. Okay, hold on. Nava, hold on just a minute. I have a thought I wanted to talk about. So, Plasmo, are you here? So I started doing it, and I was going to put it in a book, and we're going to do 1 to 100, and go all the way, and I started messing up, and I was like, oh my God! I did it for all, and I was so upset, and then I was like doing it again, and I got to 52, and then I did it again. Oops, sorry. I did it again. Where's my other one? I did it all the way to 100. And I was gonna create a worksheet out of this. I was gonna create a workbook out of it. And I go all the way to 100. Yeah, right? So if you look... Oh, so the thing is if you look every 1 to 10 is 55. 11 to 20 is 155. And then 21 to 30 is 255. It was really interesting. Yeah. 50 is probably far enough. 50 is far enough, but I think if I broke it up, I think it'd be kind of cool to get to 100. Because 100 is 50-50. Oh, I don't know if you can see that. Hold, please. There we go. 50-50 is when you get to 100. And I kept going through it. I was like, you know what messed me up was the 50s and the 60s and the 70s. That's what messed me up. That's when it gets a little hairy. But then when you pass it, you know, it's pretty good. And then I was going to do the minus. All right. So let me find a question for multiplication before we head out, because I don't know how long it can stay on. Hold, please. I'm looking for it. Division. Hello.
Hi.
What's going on?
Nothing.
Okay.
Are you done?
Nope. I'm still live, but I'm lagging.
Oh no.
Oh no. Okay. Here, 28 times that by 3. What are we learning here? Oh, hey, Vinters! Guess what? Plasmomate gave me a really good inspiration to count by adding 1 to 100. And so what you do is you do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Are you using Starlink? I am using Starlink. I need to find... There we are. Starlink. And I guess I didn't... Yeah, that I am. That's where I am right now. Vinters, when you get a chance... Yeah, I'll print it out. So then plus 13, and then you do it again all the way to 100. So the final answer, just so you know, spoiler alert, when you get to add everything, add 99, add 98 to 100, the final answer is 50-50. What is your boo as R? Wow, lagging, huh? Yeah. Yeah. Well, I don't know where Art... What? No, I don't know what she says. So, Vinters, do you see that? So that's what Plasmo did. It's like, oh, that's brilliant. And I got messed up over here. And so I had to redo it over and over and over again. You know, if you could, it would really add it if you could type in, you write in your formulas, and then you write your answers. That's plagiarizing. I'm going to, you know what? I'll send it out. You know what? I'll send it out. You want it? I'll send it to you. And then there's going to be the backwards one. Okay. So, Nava, are you still here? We're going to do some multiplication. So, thank you everybody for joining. We're going to go straight into multiplication. So it's easy. Why is it easy? Because we can visualize it. The first thing we're going to do is we're going to understand where to put our starting point. I'm hoping you guys can hear me too, because I'm not using my regular microphone. So we have 3. 1, 2, 3. Why are we doing that? The reason why is because the question tells us that we can do it. So I don't understand why in American math, in mainstream math, in traditional math, why don't we just understand what we're looking at? We have 3. We know our answer is going to be in the 100 somewhere. Let's check it out. So what we're going to do is we're going to do distributive property. Because we're going to distributive property, hold on, please. I'm tired of trolls. Okay, so what we're going to do is we're going to have distributive property. Distributive property. What does that mean? Distributive property means that we're going to go this time 3 times 2 and then 3 times 8. So the first thing we're going to do is we're going to count 1, 2, 3, 1, 2, 3. This is now going to be in the hundreds. My answer is going to be somewhere in the hundreds. Right? 1, 2, 3. So the first thing we're going to do is 3 times 2 is equal to 6. Notice it's a single digit. We have to make it a double digit. So 0, 6. There's a leading 0 and a 6. That's how we make it a double digit. So it's 0 and we add the 6 over here. That's it. And then what are we going to do? We're going to do 3 times 8. 3 times 8 is what? 3 times 8 is 24. Right? plus the 2, 1, 2, plus the 4, 1, 2, 3, 4. So my final answer is, what's my final answer? What's my final answer? 84. Thank you so much. 84. Apparently, voodoo claps don't know that this is distributive property. Okay, that's it. And apparently, voodoo claps doesn't know how to spell. All right, so how are we doing? Does that make sense? Nava? That's it. That's multiplication. Oh my gosh. Cool. They had algebra for it. They even knew it was algebra. Yeah, right? Love it. Yes. Thank you so much, everybody. Thank you so much. Maybe I'm going to... That makes sense. That makes sense with the sense. How is it 84? 84. Oh, that's a good question. Thank you, Cordy. So then we have 84. 5, 6, 7, 8. So all the top beat is a value of 5. We have 5, 6, 7, 8. This one is 4. 1, 2, 3, 4. Notice that the 5 is not touching the reckoning bar, so it's not counted. So we have 4. If I added this, right, if it's added to the reckoning bar, this would be 9. 5 plus 4 is 9. And then we have this one is not counted, so that's why this is 8. 5, 6, 7, 8. But I'm going to go back. This is 4. 1, 2, 3, 4. So when we count, we could do 1, 2, 3, 4. Hello, Shani. And then we have 5, 6, 7, 8, 9. And then we have 10. That's what 10 is. Cordy, you okay? Does that make sense? One more. Oh, why are we putting the 0 in front of the 6? Because we want to make it a double digit. You know, like we have a time. When we do time, 11:06, or we do 12:01, we don't say 12:1. That doesn't make sense. We have to put a 0 in front of this, right? So if we want to make this a double digit, we put a 0 in front. That's why we do it. Coles or else. The beads give the answers. You're right, Plasmo. The beads gives the answers. Sad panda. Voodoo is just sad. All right. Cool. So, okay. So, Ariana, we have 1, 2, 3, 4, and then 5. The top beat is 5. Oh, I already blocked them. Low and dry. Yeah, not a problem. Thank you so much for the question. I appreciate you. Keep your mind open. Everybody, please keep your mind open to something different.
Now open your mind to me, please. Open your mind.
Okay, cool. So we have 5, and then we have 6, 7, 8, 9, and then we have 10. 1 and 0. Then we could say 100. After 100, how do we do it? We do 100. So we have our ones, tens, hundreds, thousands. So we could do thousands, 1, 0, 0, 0. And then we could do 10,000, 10, 0, 0, 0. That's what 10,000 is. So if the number was 6 of 2, I'm paying attention. Oh, thank you, Ariana. If the number was 6 instead of 2, yes, it would still be 0. It would still be 0 because it's a single digit. Because it's still a single digit. It would still be that, if that makes sense. So the whole thing about double digit, single digit, right? We would be 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, and 0, 9. Yes. Thank you, Tumble Dry Low. Thank you. And then 10 is double digit. So the first double digit is always going to be 10. It's to avoid confusion. That's correct. Even when you do file names, right? When you do your file name, I know in Windows, if you want to do it file name, you do 01, 02. You could do 1, but then the problem is you'll have it will look like this as a file name. And then that would be 12. Yeah. we are focused on the lesson and we forgot to tap. Don't worry. I appreciate everybody tapping and those of you that keep your mind open. Thank you so much for joining and being open. Yes, in sequence, right? So that's why we do this, the leading zero. Okay, I was asking because I imagine the zero is behind. Oh, yeah. Yeah, we're dealing with the 10th place. Yeah, exactly. No, thank you, Coles or else, because it makes sense, right? And so when we're looking, right, we could do, if we did 6, 0, that would be 60, which is different than 0, 6. 0, 6 would look like that. Yeah. Okay, cool. So, shall we go on to adding and subtracting? So were you here for what 4 plus 4 was? So if you sorted the number numerically, yes, exactly, instead of 1, 2, 3, right, exactly. 60 times 2. All right, so thank you. Thank you, Plasmo, for the question. So we're going to do multiplication. Again, we're going to have a conversation, right? We're going to take a look. This is analysis. And so what we're going to do is we're going to look at our number and we're going to see. What we're going to do is we see 1, 2, 3. Because there's 3 digits, I know I'm going to be somewhere in the hundreds. So when we look, we're going to do 2 times 6. 2 times 6 is different. We don't need to say 2 times 60 in the abacus world. Why? Because the abacus keeps track of our numbers. All we need to do is say 2 times 6 is equal to 12. And if you notice, I put 1, I put 2, I have 120. 3 places. Thank you, Vinters. Yes. So it's 3, right? Even if we did 6 times 64 times 2, right? It's the same thing. 1, 2, 3, 6. We don't need to say 60 times 2. We just say 6 times 2 is equal to 12. 1 and then 2. And then we do 2 times 4 is equal to 8. 8 is a single digit, so what do? It's going to be a 0, 8. So we can push it to the next column over. So it's 0, and then there's 8. I got put in special ed. You know, funny, abacus is used in special ed, which is really strange. And then it's also used in an enrichment program. But it's like, I should teach the regular people, the average people, how to use the abacus. I'm teaching the matrix how to use the abacus. So, but yeah. And so for my final answer is 128. Should I always use a 0? Only for single digits. Only for single digits. If it's double digits, you don't need to. It's only for the single digits. Tumble dry low. There's no... thank you so much for checking in. Hello, everybody. Hello. This is a little different. Thank you so much for the rose. Andre? Anybody have a question? Yeah, I know. I think I'm going to have to end it pretty soon because I'm lagging. I think it's me, and I apologize. Okay, how are we doing on the questions? So we could continue on. So what we could do is, 4 plus 4? Or we do, 15 plus 37. Does the place count work with division? Yes, it does, but we have to do minus. Yeah. So let me find a question for you. Excuse me. But it's minus. So when we do it, Okay, we'll do this one. Yeah. Plasmo. Okay, hold on, Plasmo. We can do... Whoa. You guys are so funny. All right, here we go. 9 plus 5, and then we got to do 99 times 9. Haven't done division yet. It's confusing. It's not confusing. It's just unfamiliar. So before we go, let's do 9 plus 5. Well, what's plus 5? Plus the 5 is equal to what? We're doing this one. Plus the 5 is what? Plus the 10 minus the 5. Plus the 10 minus the 5. Why? Because 5 plus 5 is equal to 10. What we're doing is we want to make this 5 into a 10. So that's why we get to take it from the 9. So my final answer is 14. Thank you, Plesmo. Yes. So it's minus the 5. So what did we do? We substituted this information into here. Okay. So then what's the next one? The next one is this one. 37. So 37. I'm going to erase this. Plus 1. Plus 5. Plus 5 is equal to plus the 10 minus the 5. Plus the 10 minus the 5. Let's minus the 5. And then we're going to plus the 10. Plus the 10 is equal to 1, 0, 1, 0. So we do plus the 5 minus 4. Plus the 5 minus 4. So my final answer is 52. Winters, I make it look easy. That's what 20 years of abacus. Okay, we have 99 times 9. Let's see. 3. 9 times 9 is equal to 81. Add the 80, add the 1. And then we do it again. 9 times 9 is 81. Add the 8, add the 1. So my final answer is 891. Thank you, Vinters. Yeah, I'm 26. I'm even good at math. I'm on my start charting life. Oh, thank you, Dank. Yes, 81. Hey, Shiny. I got to practice. So, for those of you that just joined, thank you so much for joining. Let's do a little review. And what we're doing is we're visualizing our numbers. So we have 8, 5, 6, 7, 8, 9, 1, 5, 6, 7, 8, 9, and then 1. That's what this is. 891. So, Dank, I'm not sure if you got this, but let's count. 1, 2, 3, 4. We're visualizing our numbers. This is what 4 is. The top bead will always be 5. We have 5, 6, 7, 8, 9, and then we have 10. 1 and 0. 1 and 0. The way I practice, I look around the house for numbers and I add and subtract. You could do that. That's a good one. Or you have all your receipts. That's a good practice. But then the other practice would be going from 1 to 100. That's a good one too. I forgot about this one. We used to do this for the kids. We used to have this as a warm-up for the kids, but then realized it took a long time. Yeah. So, yeah, go all the way to 100. You could try that. No, I'm sorry. Yes, it's just math with a sword. Yes, exactly. Chaotic. This is algebra? No, this is not algebra. Dank, if you're looking for algebra, give me a DM and I can tell you who I can give you a person. She does algebra all the time. I don't do algebra. I only do abacus. I only do visualizing arithmetic. Oh, so we're doing our next number. Yeah. Yeah, give me a DM and I'll send you to her. Her name is Audrey. And she goes live every day. Sometimes twice a day. All right, cool. So our next number, we're going to do division. We have 8, 2, 4. Divide that by 2. This will be easy. Just went to the Lego. Hey, yeah. I have a large receipt to practice with. Oh my God, that would be expensive. Whew. All right. So here in division, same thing. What we're going to do is we're going to count. We have 3. 1, 2, 3. 3. Take away 1. We have to figure out our... So what... Oh, my goodness. So what are we doing? 1, 2, 2. 2? Oh, I think I need my other abacus. Do I need my other abacus? Hold on. Let me check. Yeah, I need my other abacus. Yeah, I need it. Hold on. We're going to put in our dividend. 8, 2, 4. This is just here as a placeholder because we want to know what it would look like. right? We all right? Okay. So now we can compare. Now the difference between mainstream math and Abacus is that we do comparison. We actually critically think what we're trying to do. So if I'm going to go here, right, this is where I'm going to the quotient. My question is maybe I should do it here. 2 times what is equal to 8 or less? 2, but because I can do it, I need to skip this column. Because I can do it, I have to skip this column. So I'm going over here. Yep. So what times 2 is equal to 8 or less? 2 times 4, right? 2 times 4 is equal to 8. So I put my 4 here. There's my quotient. I put my 4 here, and I have my 8. And I take that away. So my next one is 2 times what is equal to 2? Again, because I can do this, I'm going to skip this one and go here. So my answer, my quotient is 1. And I take away 2. I do it again. 2 times what is equal to 4? Right? Again, because I can do this, I'm going to skip this column. I'm going to go here. 2 times 2 is equal to 4. I put my 2 here, and I take away the 4. Thank you, Vinters. Thank you, Plesmo. Yes. So my final answer is 412. So what we just did is we did it through the Abacus way. And what we do is we go through the multiplication. Can you do square root? You can, but I don't know how to do it. I don't remember how to do it. I don't remember how to do square root on the Abacus, but you can. You'd have to look for it. Yeah. Does that make sense, Vinters? So you could still do your place value, but you instead of doing adding, you subtract because division is subtraction. Yeah. And it's simple. Do you always put the problem on the Abacus? For division, I do. Yes. Because the problem, the dividend, keeps track of my quotient. I don't know how everybody else does it in the Abacus world, but I do it because I want to keep track of my quotient. Notice I kept my quotient kept moving over because my dividend keeps moving over. Yeah. So I did, yeah. So that's what I did. So it'd be 2. So notice 8, right? 2, 4. I would keep moving it over, right? Now, was it 2, 4, right? And then here I had 1. I have to skip this column and go over here. So then my answer is 1. So I take away 1. So notice now my quotient moves to the next column, just like my dividend moves. Can you do a random using 4-digit by random 4-digit? I can, Turtle, but then there might be really complex process, but you can, but it'll be a little bit later when everybody understands it, if that makes sense. Thank you so much for liking the live, everybody. Thank you so much. I wish I knew this way in school. Oh, yeah, it's really interesting that you can visualize everything. So for those of you that just came in, we can count on the Abacus. So we can count 1, 2, 3, 4. But what we're doing is we're visualizing the number. This is 4, and then this is 5. The answers will show up. You just need to learn how to move the beads. So this is 5. We have 6, 7, 8, 9, and then we have 10. 10 is a 1 and a 0. We have 11, 12, 13, 14, and then 15. 1, 5. 5. So if I did this is 55. This is 555. This is 5,555. Every time the beads are touching the reckoning bar, it's being counted. What if I had where you have a remainder? If you have a remainder, Michael, if you have a remainder, then it stays on your Abacus. That's all. I printed out the problems generated on the internet. Can you do 2 divided by 4 random numbers? Are you send the memory of a cool? Thank you. Hold on. Let me see if I can find an easy 2-digit. I can't do 2-digit. I didn't do that yet. I could do 3-digit. Can I do 3-digit? I can do... Okay. Oh, you know what? We could do this one. This one will be... Let's see if we can do this one. Hopefully you guys will... Hopefully this will make sense to you. 5, 4 divided by 3, 4, 5, 6. All right. So, what are we going to do? Abacus. Here we are. When we do this, we have to pay attention. 1, 2, 3, 4. 4 take away 2 is equal to 2. Right? 1, 2. So we're going to put our number 3, 4, 5, 6. Now, the first thing we're going to do is we're going to take the first number, this one and this one. 5 times what is equal to 3? That doesn't make sense. You can't do that. You need to bring down the number. What number do you bring down? I need to make this a double digit. What number do I bring down? Four. Thank you, Michael. 4. So I bring down the 4. So something times, what are we doing? What times 5 is equal to 34 or less? 5 times 6 is equal to 30, right? So I'm going to put 6 is my quotient. Take away 3, take away 0. Then because whatever I do the first digit, I got to do the second digit. 4 times 6 is equal to 24. Four times 6 is equal to 24. Take away 2, take away 4. Now what am I going to do? I got to do it again. 5 times what is equal to 2? Can I do it? No. What do I do? I got to make this a double digit. Uh-oh. Am I? Oh, there you are. Okay, I'm still here. Yep. Not 0. Not 4. Not 4. If you look at my dividend, look at my dividend. There's a 2, there's a 1. The 1 goes here. That's why we got to go here. It will tell us. Right? We have to go here. 2 and a 1. So 5 times 4 is equal to 20. Put the 4, take away 2, take away 1. Then what do? We do 4 times 4 is equal to 16. Oh, I did that wrong. Oh, yeah, there we go. Oh, yeah, I did that. Yeah. So my final answer is take away 1, take away 6. Yes, I thank you, Plasma. I still have 1. Yep. So my final answer is 64. Oh, yeah, so my answer is 64. But notice that because I put my dividends here, it tells me where my quotient is. Much faster. It is. It's much, and you don't need to do 4 times 2. Right? Because what do? In mainstream, you actually have to do it all, right? You have to do 54 times 2, and then 54 times 3, and then 54 times 4, right? Okay. Difficult? It's not difficult. It's just different. Thank you, Tooth Hole, for the heart me. Thank you for checking in. Thank you, Goat. Thank you, Dr. Guy. Thank you so much for the gifts. Right? It is harder to do it this way because we don't have our multiplication table. This deals with our multiplication table, but you just need to know whatever you do to the first one, you got to do it again with the second one. That's why we do this. 6 times 6 or 4 times 4. Yeah? Easy. Easy. Easy, Plasmo. Easy. Yeah, there's my light. Maybe I should do that. No, can't do that. Maybe I should do that. I don't know. Okay, how are we doing? Does that make sense? So that was the division, which is different than mainstream. Mainstream, yeah, this one is this is difficult. Are you camping? I'm camping. Actually, the kids went fishing. The mechanics of division are a little hard, but with practice we can solve it. It is not hard. It is unfamiliar. Unfamiliar. I'm not used to the setup. TikTok T said the same thing. What happened to your camera? Prefer the abacus, except division. Definitely addition and subtraction. Yes, division and subtraction is always better, right? So we can even do this. Let's do this. We could do... Oh, you know what? We could do 183 plus 6. Oh, that's easy. What am I doing? 62? No. 7. Let's see. 208065. Unfamiliar. Yes, unfamiliar. So we could do this. That would be easy, right? Because we know our numbers, we know how to do it. So 21208, right? So we're going to add the 6, add the 5. Well, can't add the 6. What do? Plus the 6 is equal to plus the 10 minus 4. Plus the 10, take away the 4. Can't take away the 4. What do? What do we do if we can't take away the 4? Now we have to know how to plus the 10 and how to plus the 5, right? Plus 5, how to 4? 4. 4 plus 1 is equal to 5. Same thing as minus 4 minus 1 is equal to minus 5. So how do we do this? Right, it's the 5. So minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. And then add the 5. So my final answer is 201, 4, 5. Yeah. Yeah, I think it's just interesting how to do it all. Oh, that would be great. Here we go. So we have 6827373. Oh my god, I did it in my pretending to use that. Chaotic, right? That's what I'm saying. It's so much easier when you see it. That's so funny. Okay, what are we doing first? We have 6, 8, 2, 7. There we go. Right? We have 8. That's chaotic. That's what I'm saying. It's funny. Once you can see it, you cannot unsee it. It's so funny. No, you're right. We cannot add the 5, Plasmo. It's kind of right. It's mind blowing. It's mind blowing. Where's my mouse?
Oh, I can see everything.
You guys, this is the way.
This is the way. This is the way. This is the way.
No, this one right here, right? 8. We cannot add the 5. So we have to plus the 3 is equal to plus the 10 minus 7. So plus the 10, take away 7. And then we add the 7, and then we do it again. Plus the 3 is equal to plus the 10 minus 7. Minus the 7 plus the 10. 1, 0, 1, 0. Cannot add the 1. Plus the 1 is equal to minus the 9 plus the 10. Minus the 9 plus the 10. So my final answer is 7200. I just feed a baby with a bunch of space. Right? That's what I'm saying. It's so much easier if you do it this way. So much easier. See? Oh.
Now open your mind to me, please. Open your mind.
See, welcome everybody to the Abacus.
Welcome to the real world.
To the real world. Welcome to the real world. I forgot. Welcome to the real world. I'm teaching Abacus to the Matrix. It takes a little bit. I'm not gonna lie. It takes a little bit, but at least once you get it, right? Oh my goodness. All right. Hold on. Your audio board is camping with you? Yes, I'm on my laptop. That's why. Oh.
To the real world.
Sorry. Okay, hold on, Plasma. Let's do 7, 6, 7, 6, 9, 1, 7, 3. Okay. Here we are. We're going to do 56 plus the 4, right? We plus the 4. Now we need to plus the 7. Plus the 7 is what? The real world. What's the 7? I'm telling you, I've been living in the real world for such a long time. It's hard for me to... 7. How do I add the 7? 7 is equal to plus the 10 minus the... You know what? I'm sorry. I apologize for being selfish. Thank you so much, Chaotic. I'll see you later. Have a good night. Oh my gosh, it's 10 o'clock. All right. This one will be my second last one, and then we'll do Plasmo, and then we'll be done. So we have 1. We can't add the 1 here. 1, 0, 1, 0. Cannot add the 1. So it's minus the 9 plus the 10. Minus the 9 plus the 10. And then minus the 3. Cannot minus the 3. What do we do? Minus the 5 plus the 2. Minus the 5 plus the 2. Minus the 5 plus the 2. So my final answer is 103. All right. Last one. And then I'm going to go get some s'mores. We have 176. 176. Right? And then we do 7, 6. Plus 6 is equal to 1. Plus the 10 minus 4. Plus the 10 minus the 4. Cannot minus the 4. Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. And then we have to plus the 9. Plus the 9 is equal to plus the 10 minus the 1. Plus the 10 minus the 1. And then we do this. Right? So what we're doing is we do a running total. Right? I don't do the ones first. I don't do the 10s and then the hundreds. I do a running total. So right now my running total is 945. 945. And then I need to add 173. Add the 1 plus 1 is equal to plus the 10 minus 9. Plus the 10 minus the 9. Plus the 7 is equal to plus the 10 minus 3. Plus the 10 minus the 3. And then plus the 3. So my final answer is 1118. This was a fail for me. Oh, interesting. So, Plasma, when you do it, you have to do a running total. That's the only way Abacus does it. Abacus does it a running total. So we do this, then we do this. Thank you. On my worksheet. Oh, really? That's very interesting. So you're doing 3 lines now. That's when you do 3 lines, it's always going to be a running total. Yeah. And when you do it, I would always have the total here, so that you could always go back and see what you've done wrong. You know what I mean? Just like I did here, you keep a running total. Every number you keep, because then you could see what you've done wrong. If you don't keep your running total, if you don't write it out, then you won't know what your answer is. Yeah. So like I figured out what my problem. Yeah. So notice I keep making mistakes, right? You keep where you gone wrong until you become proficient. But even those until you become proficient. But yeah, you keep a running total. Because if I just kept doing it over and over again, you'll never know where you got wrong. So yeah, keep a running total. Right? So like if we did this wrong, we can always check it. Yeah. When I was teaching the kids, I would always give them a running total. Because it would suck. What happened was they would have like 10 lines, and somewhere around here they would get it wrong. It would suck that they would have to go back again. So I always tell them, keep a running total, so then you always know where to go back. Yeah, thank you. Thank you, Plasmo. Thank you, Vinters. Thank you so much for taking me all the way to 10K. You guys are awesome. You guys are awesome. I apologize for the lag. I just didn't want to, yep. Over and over. Yeah, because if you never know what you did wrong, then you just run yourself insane, right? So, but yes, thank you everybody for joining. I know it's a little bit different. I'm actually going to be back tomorrow, the regular setup. But I appreciate everybody here. Thank you so much for joining. I do have books available in my TikTok shop. I didn't do a good job of pinning it. I apologize. But I do have books available, and I do have the Abacus available in my TikTok shop for anybody that is interested. Have a great night. Yes, you too, Vinters. Thank you so much for the questions. The questions were really good. And keep up with your good work. Thank you, Michael. Have a good night to you too. Bye, everybody. Okay.